Alright, class, we're starting the absolute value unit. Our textbook actually doesn't have an actual unit for it, so it kind of jumps around between different sections. So we're going to start with section 2.5 here, and we have two learning targets. It's just to kind of introduce what absolute value is. So we actually did, or you should have done, a discovery activity for this, but we'll just do a few reminders that are similar to what the activity is like in case you didn't do it. So learning target, I'm calling it AV1, absolute value 1. I can evaluate absolute value expressions. Evaluate means to give me an answer. It's just a word for order of operations. So just a reminder there that the definition of an absolute value is referring to the distance between two numbers. So instead of saying something like for example here, translate each statement into equations using absolute value symbols, and then determine if the statement is true or false. So like example A here, it says the distance between 7 and 10 on a number line is 3. So instead of writing that whole sentence, mathematicians will use this symbol, kind of like a parentheses. It acts as a parentheses. So the distance between 7 and 10, so distance we show by subtraction, is 3. And that's true, right? So if I were to create a number line, it says the distance between the number 7 and the number 10 is 3. And that is true. There are 3 spaces in between. Letter B, I would like for you to just do on your own. Just translate it into a sentence. The distance, or I'm sorry, into a mathematical expression using that absolute value symbol. The distance between -2 and 5 on a number line is 7. So it should look something like this. Absolute value symbol, -2, and then -5, because distance we use subtraction, is equal to 7. Yeah, and then again, if I were to show you a number line, that would be true. There's that number line right there. There are 7 spaces between -2 and 5. So now on the flip side, what I want you to do is, and I know this is going to be a pain, but I want you to write me a sentence just like the first examples there. Now, what is this absolute value statement saying about the distance? So for example, I have the absolute value of 21 minus 25 is equal to 4. And so what that means is the distance between 21 and 25 is 4. So I want you to write that out. Just like that. I want you to do the same for D. What is this equation translated in words, English words? And that's what you should have. So this is just kind of a review of the activity, and I think it's just to kind of make sense of what absolute value is, instead of just kind of memorizing some sort of formula or what it does. So let's kind of scroll down to the next part here. Now that we kind of have like the definition of it, we're going to actually go into the learning target. We're going to evaluate using the absolute value. So if you remember the order of operations, we now have to think about where does absolute value fall under. So the absolute value actually falls under the parentheses. It's the same as the parentheses. So if you see it, it is the first thing that should happen. So evaluate. Here's example A. The absolute value of 4 plus 6, absolute value, and then minus 14. So I'm going to take that absolute value of 4 plus 6, which is 10, and minus 14. Now the absolute value, what we notice is distance is never negative. So that's what absolute value is, right? And so to drop that absolute value, this answer here is just 10 minus the 14. And then I'm going to continue on with subtraction. So what absolute value does is it makes whatever you evaluate inside into a positive, into that positive distance. So try example B on your own, and then just kind of pause the video and then try it. So inside my absolute value, I have 3 minus 4 times 2, which is 8. And then what this is really saying is the distance between 3 and 8. Alright, so the distance between 3 and 8, essentially, honestly, I don't even really need this step. But that is what I'm answering. The distance between 3 and 8 is 5, right? But I'm just kind of showing you that one extra step. 3 minus 8, which is negative 5, but the absolute value of that is positive 5, and then I kind of bring everything else down. 23 minus 5, which is 18. Try letter C on your own. So the distance between negative 6 and 1 is 5, right? So negative 6 plus 1 is negative 5. Absolute value of negative 5 then is positive 5. The distance is positive 5. And then I got to make sure to do multiplication first, so 5 times 5, and then subtraction. And then this just kind of dwindles down to a fraction, negative 7 fourths. If you do need to pause and rewind, please do so after you've copied down all the notes. Otherwise, I'm going to move on to the next part. And so the next part is our next learning target AV2, absolute value 2. I can solve absolute value equations. Now, again, I'm going to kind of recap a little bit of what we did in the activity. The direction says rewrite the following equations as a sentence, then draw a number line to find the solutions. So this first example here, A, I have the distance between a number and 3 is 4. So I want you to write that sentence. Again, I know it's kind of annoying to write that sentence, but there is a point to it, right? And then I want to draw a number line that kind of shows this mystery. Now, we know the obvious number, right? The obvious number is 7. So here's the 3, and it says the distance between some number and 3 is 4. So 4 spaces, 1, 2, 3, 4 spaces. But 7 isn't necessarily the only one, because if you go the opposite way on a number line, 1, 2, 3, 4 spaces, you also kind of land on negative 1. So the point is that, like, it doesn't specify which direction you're going. It doesn't specify if you're going more positive, or it doesn't specify if you're going more negative. All it says is that the distance between this mystery number and 3 is 4 spaces. So I actually have 2 solutions here. I have the possibility is x, or x can equal negative 1, x can equal 7, or negative 1. Depends on which way I'm going. And since it doesn't specify, I don't really know which one. So try letter B with that foreknowledge. And including, so I want you to write a sentence, I also want you to draw me a number line, and then find me that solution. Here's what you should have. The distance between a mystery number and 9 is 1, just 1 space. So my number line here, if 9 is in the middle, a number that's 1 space away from 9 can either be 8 or 10. Again, it doesn't specify, so I have to assume that it might be both. So what's my point here? When you're solving for absolute value, you have to think about there might be 2 possibilities. There is the possibility that it's the positive 14, like it's moving up 14 spaces, or that it's actually moving 14 spaces to the left on the number line. So like for C, sorry, that's what I'm doing. So like the distance between 2 times a number and 6 might be positive 14 spaces, but the distance between 2 times some number and 6 can also maybe be the negative 14 spaces going left. And so that's kind of what's happening, and then you're solving for x. So adding 6 on both sides, like that, and then dividing by 20. like that. And so one of the possibilities here is 10. So if I'm moving 14 spaces up, positive in the positive direction, then the number that they're talking about is 10. But if I'm moving 14 spaces the other way and I solve it the same way, add by 6, divide by 2, they could very well be talking about the -4, right? Because -4 is also that many spaces away. And so these are my two possible solutions. I want you to think about D. Try letter D. Now, you may have split up the equation and given me the negative and the positive like this to get x equals 5 or x equals 11, but that's actually not true. Because if I plug 5 into the absolute value, this is kind of what I get so far, but then the absolute value represents the distance, so that should be a positive 3. But I get positive 3 is equal to -3, which I know is not true. So that means 5 is not a correct solution. Same also if I plug in 11, I get kind of the same thing, so the absolute value of 3 is just 3, positive 3. But again, I get the same thing. 3 is equal to -3, which again is not true, so that means 11 is not it. So what went wrong here? I want you to think about this statement again. Here, let's translate this into a statement. This math equation actually says the distance between a number and 8 is -3 spaces. That can't be true, because when I'm talking about distance, like I never talk about -3 miles. How much did you run? Oh, -3 miles. Even if you run backwards, you're still running a positive 3 distance. Right, so this actually is not possible. So what that means is there's no value for x to make this true. So that means there aren't any solutions to satisfy this equation. So again, distance, you got to make sure the distance has to be a positive number. Let's move on. If you need to take a moment to kind of pause, rewind, maybe watch that last part again, by all means, go ahead and do that. Otherwise, I'm going to kind of move on here. So, I mean, our ultimate goal is to solve, right? And it's kind of to solve each equation without using a number line. And so now we've kind of taken into consideration, right? The distance between a number and, so if you actually think about this, distance is always subtraction. So how do I change this addition into a subtraction? It used to be minus a negative. So the distance between a number and -3 is 8. And so again, we want to make sure to think about that negative going to the left, right? That's all that means, that negative number. -8 spaces or I'm sorry, 8 spaces in the negative direction or 8 spaces in the positive direction. And then when you subtract 3, you get negative. It could be -11 or it could be 5. Like these could be the two possible choices. Why don't you try number 2 again? You know what? Let's do number 3, and then I'll have you do numbers 2 and 4 on your own. So number 3, you want to make sure the absolute value is isolated, right? So what I mean here is that right now, I want to kind of get rid of that 9 first, and then I have the absolute value of x plus 3 is equal to 3. And then now I want to think about the negative version the distance towards the negative versus the distance towards the positive. So isolate that absolute value symbol first before actually splitting up that equation. Alright, why don't you finish number 3, find what that number is, and then try numbers 2 and 4. So finishing off number 3 here, x could equal the -6. They could be talking about the -6, or they could be talking about 0. Number 2, if you look at this carefully, it is saying the distance between some number and 1 is -3. Again, we just kind of talked about that you can't travel -3 spaces. So that's no solutions. There is no number like that. Now for 4, you want to isolate the absolute value, so subtract 9 on both sides first. And then here, the 2 times the absolute value, x minus 6. You know what, let me just kind of pause first, or not pause, but let me just take a teaching moment here. Some people will think, again, because like the absolute value is so similar to parentheses, that like, oh, I can distribute this. No, in that sense, that's where it's different from parentheses, right? You can't really distribute. You can't add anything more into what's already in the absolute value. But what you can do is divide that 2, because if it's 2 is being multiplied to that whole thing, then you can divide it to cancel, so it divides on the other side. But then again, I have now the distance between a number and 6 is -2, but again, that's just no solution. If you kind of need to see that again, pause the video, rewind, otherwise let's move on. So this could look a little confusing here, but let's say the solutions to an absolute value problem are 11 or 19. So we might be wondering what may have been the equation that we started with. So what you want to do is, like, here are my n's, and you want to kind of think about where, like, what was the distance they were talking about. So essentially you just kind of want to meet where the middle is. So like 19 and 50, like 19 minus the 11, that's 8 spaces. So that means like there must have been a number in the middle here. So 4 spaces and 4 spaces, right? So if we were to think about it, is the distance between some number and 15 is 4 spaces. So you're kind of starting with the solutions here, and you're trying to figure out what was the original absolute value equation. I hope that was clear. Try number 2 on your own, and try to think about what was the equation that these were solutions for. So the solutions are x equals 17 or x equals 27. So pause the video, try to think of what equation that they got that from. So if you said x minus 22 is equal to 5, that's good. So the distance between some number and 22 is 5 spaces. So here's 5 spaces, or it could be 5 spaces going the other way. So that's the equation that they started off with. That one's a little bit trickier. But again, if you kind of need to rewatch that, pause it, rewind it, see what just happened. Otherwise, let's move on to our final word problems. You know, I think our word problems will kind of help you with this idea as well. Snakes. Raise your hand if you hate snakes. The temperature of an enclosure for a pet snake should be about 80 degrees Fahrenheit, give or take 5 degrees. Use a number line to find the maximum and minimum temperatures, then write a sentence of your conclusion. So here, let's write out all the numbers. So what it's saying is that a pet snake should be at about 80 degrees. Now, we don't live in a perfect world, so it says give or take 5 degrees. So what that means is like it can be within 5 degrees higher or 5 degrees colder. And so the coldest it should get is 75 degrees. The warmest it should get is 85 degrees. So my maximum and minimum temperatures are 85 degrees and 75 degrees respectively. So that's kind of what that's saying. Try the ice cream one on your own. Ice cream should be stored at 5 degrees, give or take 3 degrees Fahrenheit. Write and solve an equation to find the maximum and minimum temperatures at which the ice cream should be stored. So this one is actually saying, without using a number line, write an equation. You know what? I'll do this one together with you. So if it should be at 5 degrees, so like some distance, a number between, the distance between some number and 5 degrees should be 3. So the distance between some number and 5 degrees should be 3. So since 3 is, I can go 3 more, 3 degrees warmer, or 3 degrees colder. So that's kind of my equation right here. So if I want to go 3 degrees colder, that means I'm going towards the negative direction, or if I want to go 3 degrees warmer, then I'm going in the positive direction. So my temperatures can be 2 degrees Fahrenheit, or it can be 8 degrees Fahrenheit. So those are my two options there. If any of this video, I know it was a long video, but if any of it didn't really make sense, pause it, go back to the section where you need to watch it again. Otherwise, you can move on to trying to practice these two learning targets.